hot over here, but it's very humid today.
Mm.
And that's past few days. It was very hot, but it was dry like usual. And
Mm-hmm.
today it's cloudy outside. We have mist, but it's still hot and
Yeah.
terrible weather.
Yeah, there's no
I
way to
hope,
get away from it.
yeah, I hope it's better on your side.
It is not. Well, it is not humid,
Oh,
so. But yeah, it has
but
been hot for many weeks in a row now, and not going to cool down very soon.
yeah, but your advantage at your side it's in Fahrenheit, you know.
Yeah.
that's that's more
Uh-huh.
impressive.
Yep, so we actually get into 3 digits.
Yeah, yeah.
Good evening. Good evening, Caden.
Hello.
Hi, Caden.
I was too tired and fell asleep last week.
Oh,
Yeah,
absolutely. Yeah.
because I was preparing some teaching material for the upcoming course.
Yeah.
Yeah.
Yeah. So what are you subjecting your students to this time?
I'm just a normal TA this time, so
Mm-hmm.
the only thing I need to do is like fixing some error in the materials and
Mm.
holding the office hours. The office hour is at the evening because the course is for everyone, not only the students in the university.
Oh,
So
okay.
maybe the following weeks, I mean like half a year, I may not be able to be with you guys.
Okay.
Yeah, I'll catch up if I come home early enough. Yeah.
Okay. Um, okay. Yeah, we'll come up with some mechanism that we can use to stay in touch, so that yeah, we don't get too far out of sync.
I'll still watch the video.
Okay. Excellent. Yeah.
Yeah.
Would like to hear from you as well, and understand what's happening in your world. So. So yeah, we'll have some sort of two-way communication. Maybe we can use Discord. Maybe we can
Yeah.
do email, whatever.
I'm sure I'll still have questions because I'm still reading the book.
Well,
Yeah.
very good.
The course is about the kernel stuff, so
Mm-hmm. Yeah, so you have
it's
some.
a little bit tedious. Yeah.
But it sounds like you have some adult learners, some people who are going to the regular day job, and then afterward coming to the course. Is that right? Or at least office hours. Yeah.
Yeah, people need to. If they have some question, I need to answer.
Very nice.
Yeah.
Yeah,
And
there's
now
a.
I've seen the video of the last week.
Mm-hmm. Yeah,
Good
that
to
was
see
some.
the progress.
That was some pretty exciting stuff.
Yeah.
Yeah, well, since then I have published version 3.1, so now that capability is in everybody's hands, and just now before starting the call, finished updating the starter kits, so they all have the new version and they all take advantage of the endpoints.
All the starter kits that we used on the website, in the documentation.
Yes. Yeah, so there are 4 starter kits, 2 in JavaScript, 2 in TypeScript, and then 2 with React, 2 without.
Yeah. Let's see.
Oh, and also, Michael, I have mentioned Jinaga in the conference.
Oh, yeah.
In the last weekend, I attend a conference called Cost Cup. I'll post the link in the general channel.
Awesome.
It's a conference that aiming for the open source community, and we have a lot of tracks and also some room for people to chat.
Mm-hmm.
So I have introduced Jinaga to some people that are also interested in the immutability.
Mm-hmm.
I hope they will give it a look. Yeah.
Yeah, I hope so too. I really want people to to really exercise the system and and give me feedback on what's working, what's not working. Yeah, that just helps everybody to make this a more useful tool.
It's a Taiwan conference.
Yeah.
Yeah. Caden,
It's
are you
almost
from?
the biggest one. Yeah.
I know it's a dangerous question these days to ask. Are you from Taiwan or from China?
Taiwan.
Okay.
Yeah. And Hello Kitty just left, so it's a little bit dangerous here.
Mm.
No. Okay.
Yeah, it's like a storm, you know.
Yeah.
Yeah.
It's not. It's not the only place in the world where it's dangerous these days, I think.
Yeah, but yeah, the only thing we can do is just hope things will go in well.
Yeah. I hope so too.
Yeah.
Yeah, so the conference that is almost the biggest one. So there are many interesting developers.
Mm-hmm.
Yeah, so I've met many interesting people there also, as well.
Yeah. Is there a specific primary focus for this conference?
Um, there are like 30 tracks, I think. There are many different communities in this conference holding tracks for each, and I think the most popular one is about the back end technology and or the cloud technology.
Mm-hmm.
Yeah, so there are many database people there, also many like Kubernetes guys and some I don't know language specific or some cultural related. It's like a lot like FOSDEM, you know, in Belgium. A little bit
Hmm.
like the FOSDEM. Yeah.
That doesn't say me a lot, but okay. But actually, everything is online. If you click on these day 1, the day 2, day 3, day 4, it goes to YouTube, and you have a full recording.
Hmm? Is it up now?
Yeah,
Let me
yeah,
check.
yeah.
Oh yeah, it's up.
Yeah. I was
Michael,
able
first thing I
to.
read,
Uh-huh.
first thing I read there, immutable by default.
Hey,
But
let's do that.
but the title is what makes Rust different from C.
Okay. Okay, that's a good start. That's a good start. I am a big fan of immutable languages.
Mm.
Yes.
Oh, I didn't know that.
Yes.
I switched off the the sound not to interfere.
Yeah.
I think most of it is in Chinese.
Yeah.
Yes, like we prepare some like 1/3 of the talks are in English for the international attendees.
Okay. Cool. And I believe that YouTube does a machine generated subtitles translations.
Yeah.
So that might
The
be a good option for the other 2/3.
subtitles unavailable
Ah.
for the
Okay.
moment. Perhaps they have not
Yeah.
been generated yet. It takes some time,
Mm-hmm.
perhaps.
Yeah, and they probably prioritize it based on the number of views. So let's just keep on hammering that button until they say, okay, let's go ahead and translate this. Very cool. Yeah, thanks for for bringing up Jinaga. Did you get some folks kind of interested in the progress?
Not so many, I think, but I believe people will be interested in the ability of operating immutability.
Yeah, so
I
I'm
hope so.
really pleased that the general concept of immutability has got center stage. So yeah, hopefully we can get lots of different attempts, lots of innovation around immutability, and Jinaga will be among those.
Yeah, it's a little bit of surprise uh, that people here in Taiwan are not so familiar with this kind of concept.
Yeah, I've been finding that that's actually pretty true in general. Um, when I have to describe, when I describe the concept to a new person that I meet at a conference or coffee shop, whatever. You can't get me to stop talking about it. They if they have any familiarity in this space, they either go with functional programming languages or
Yeah,
event
yeah, yeah,
sourcing, and it's like, yeah, those are both very important. Keep those in your mind. And now let's expand that. So yeah, if they're talking about functional programming languages, okay, that's great. Now take what's happening in memory and let's make that happen on a distributed system that's happening in storage over the network. And they're like, I can't make that leap. Okay, well, let me help you. Yeah, event sourcing, it's a smaller step, just from total order to partial order. But that's a math word, and so not too many people follow that step either.
sure.
All right.
But still, historical modeling. Where was it? A recent, I think, a recent presentation you gave. Something I saw offline, where you repeated all the different aspects of historical modeling, and when you get them all one by one, you say, "Whoa!" The mathematics behind the principles. Then it's amazing. It's not just one ID. It's a lot of different point of views, different findings, mathematical background that is applied.
Yeah. Yeah, and that kind of goes into this whole adoption thing. Is I was just presenting the query language to to one of my colleagues at Improving, and so so we're looking at it in Postman, and we're looking at the results, and saying, okay, so this is kind of like GraphQL. I say, yes, it most definitely is. And then, of course, the question is, well, why didn't you just use GraphQL? And that starts the conversation. Okay, well, you know, well, I started the conversation with because GraphQL assumes a mutable data store, and so of course the natural response there is that, well, you could use it on top of an immutable data store. There's so then you have to kind of walk it back and say, okay, let's start with these mathematical principles and build only from there. Now, if you do that, then you end up in a place where if an object contains a collection, that collection is immutable. You can't add and remove stuff from it. So the way that we usually model things in a data store that GraphQL supports is that we've got a parent and then it's got a child collection. And GraphQL, even though it's not explicit about this, it kind of assumes that you're going to be able to add and remove children, because GraphQL it projects a hierarchy. So now, I mean, the Jinaga specification language projects into a hierarchy, but GraphQL projects from a hierarchy into a hierarchy. So it assumes that you're starting with hierarchical data and then producing another hierarchy. Usually, the same hierarchy, just with some filtered stuff. And so it's that whole conversation of capability versus constraint. And in mathematics, the most powerful thing that you can do is constrain your problem. But people that are thinking about producing a solution, they're thinking about adding capabilities. It's just opening up the problem, and so that's always a difficult but interesting conversation. Is to say that I started with some very strict constraints, and I will not budge on these constraints. And then, because I will not budge on these constraints, I can prove these very useful things. But that means that the specification that you produce has some constraints that started from the original. I'm able to make some things possible for you, but ultimately I cannot violate these constraints. So, one of the I'm actually working with another cohort at Improving, who is working on a new internal system that is pulling information from the ImprovingU application. So the application that I've been using to test out Jinaga for the past 7 years now. And so I gave him the specification language and some documentation on it, and say, okay, you can write these specifications. I will help you, and you can produce the kind of JSON that you want with constraints. And so, he looked at this, and there's some fields that get projected into arrays. He's like, well, I'm looking for the title of a course, and you give me back an array of strings. And say, yep, I have to. I just want one string. Can you just give me? And so we talk about, hey, the concurrent edits of the title and the mutable property pattern, and it's like, okay, I get that. Can you just give me the latest one? Forget about the other ones. I just want one. And I say, nope, I will not budge on that. That you must deal with the array. The array is an important concept in the data model, and it's up to you to figure out what that means. The array is unordered. It represents a set. So it's up to you to figure out how you're going to order it. If you want to select just one element of the array, it's up to you to figure out which element. So, yeah, I think I don't think that he ended up agreeing, but at least he ended up using the specification.
Mm-hmm. Is that where you wanted to put the database from ImprovingU online?
Yes. Yes, and in fact,
Did that
it is.
happen, and is it accessible or
Yes.
not yet?
It is, and the so Jinaga is supposed to eventually have distribution rules that mean that you can select parts of the model, but not other parts, and that'll be based on who is logged in. So far, I haven't implemented distribution rules in Jinaga. So if you have access to any part of the model, then you can access all of the model. Cryptography is another feature that factors into that. So even if you can query it, if you are not the right user and you don't have the right shared key, which is encrypted using your public key, so only you can read it, then you wouldn't be able to actually read the contents of those facts, even if you could get them. So those features are coming, and in the meantime, what you can do is just authorize the endpoint using middleware, so that if you're not logged in, you can't hit the endpoint. And that's something that I could have done with the ImprovingU application, but I did not. So
we still have
yes,
to wait a little bit.
It is well, yeah. So all that to say, it is available. You can hit it right now. You probably shouldn't be able to, but you can. So far, there's not really any secret information in there that we want to keep private, but but nevertheless, it's not the best policy to open things up by default and then have to take extra steps to lock them down.
Don't tell me we have to scan the whole IP range.
Yeah. So I can demonstrate to you real quick.
Okay.
Yeah, but if you prefer to keep it hidden for a while, there is no. Let me just wait for a while, Michael. No problem.
That'll be fine. There shouldn't be anything that goes terribly wrong with this. So I have shared a Postman collection with my counterpart, and within this collection, I added some documentation. So I showed him, this is the specification language. It's really terse and just focused on getting something done. With this level of documentation, I would expect you to be able to take an existing specification and modify it, but probably not write a specification from scratch. So talk about what the specification does, what the projections do. And then I've got some example requests. So here is a request for the courses in the summer 2022 semester, so the current semester. And so you can see that it's actually going to ImprovingU courses.azurewebsites.net/Jinaga/read. So I'll make it just that much more difficult for the hackers. I'm going to read this out, but I'm not going to paste that, and I'm not going to post the collection. But if you want to follow along at home and actually use that URL, you will be able to see some data. It will be real data. You'll have to figure out how to get the public key. It is an accessible thing. It's a public key, but I'll leave that up to you to figure out how to get it. And then we say for this particular company, improving from that creator, the creator having my public key. Let's go for the summer 22 semester in the company. And then now let's look for all the catalogs in that semester. And then for each catalog is for a different office. Let's get all the courses. And then project the hash of that course. So we call that the ID. And then we've got the titles, and project that to just the title value. And we've got the instructors, project that to just the instructor value. And send that. And now we've got all of the courses that we are teaching in the summer 2022 semester.
Okay.
So one of my friends did a course called How to Read a Book. He actually he did that course in the previous semester and then reprised it because it was so popular. Eric Sal, awesome person. He's really into history, so ancient Greek history in 1 hour. And so that's what he teaches, is how to read a history book is really, and of course we're all obsessed with Obsidian right now. But then based on the success of his course about how to read a book, I said, hey, let's do a course on how to read a paper. Much less attended than how to read a book, but we had a lot of fun. So these are all the courses that are currently offered, and the important thing is that my cohort can figure out what information is going to be important to him as he imports this information into his new database. And in fact, this copy right here is the request that he started to kind of play around with things and figure out what information he wants. The ideas, that is a different part of the database that people just post their ideas. It's like this is a course that that I would like to have run in this semester. And so we do our ideation before we create our courses. So yeah, in Dallas we've got ideas about let's do a watercolor Wednesday, and Amberlease posted that idea. And here's the abstract. The abstracts are written in Markdown, so you'll see most people that post ideas don't really know what Markdown is, so they don't use it. But if we go down to any of my ideas, okay, yeah, here's somebody who used a link, yeah. Yeah, so you fetch all that information back as well. And then he wanted to be able to import attendance information, so I gave him an example query that pulls in the sessions for a particular course. So I grabbed the hash code of a course that I'd run in the past, and I knew this was a course that took place. It spanned 2 sessions, and I took attendance for those 2 sessions. So that means this would be a pretty interesting little data model. So yeah, and here I documented what are the facts that this query touches. So we're looking for a fact. We're starting with an ImprovingU session, and that has these fields, the time, place, and the created at. But it also has the ImprovingU course as a predecessor. And so ImprovingU course is described up here in this documentation. So I just provided that information to him so that he could glance over there and not have to open up the source code for ImprovingU in order to figure out what these facts look like.
Mm-hmm.
Mm-hmm.
So going through this, he's able to get all of the sessions for this particular course, so the date, time, and the place, and then the attendance records. So we've got he is bringing this into a database which is synced with Azure Active Directory, and so these GUIDs are the GUID that comes from Azure AD. So I had to bring that into the data model. That wasn't in my data model before, but I'm using the GUIDs in order to map to your key pair. So that's in the key store, which is a completely different data store. As it happens, it's the same physical database. So right now that's an issue. But in order to make this part of the query, what I had to do was create a new fact called ImprovingU user ID, and basically made that a mutable property of a user, so that whenever you logged in, it said, okay, here's the GUID coming in from Active Directory. Let me go ahead and set that property, and then you can query it. Yep, and then the present, and so it's like, I just want true or false. Why are you giving me this array of true and false? And I say, well, I am looking for the value of the ImprovingU student attendance present, which is a immutable property of the student attendance. Student attendance being a single student on an attendance sheet. So you're going to end up with multiples if somebody took attendance on their phone and it glitched out and they went to the laptop, took attendance there, and then the phone synced. But then you can just write a simple rule like, okay, if this array contains any true, then we assume that they were present. So you come up with a rule to deal with the conflicts, the concurrent edits. I'm not going to do that for you. Yep.
There is a certain uncertainty in historical modeling.
Yes, there is.
Is there a link with quantum mechanics?
Yeah, but hopefully it's a lot less spooky. And data still is constrained by the speed of light, so yeah, no entanglement here. Now, entanglement would be a really cool way to synchronize over a distributed system if you could solve the causality problem, but nope, can't actually have causality at faster than speed of light, even though you can have action. Weird. Yeah, so yeah, I published that, made that available to my cohort, and so now we are working on importing this data. And that kind of led to a couple of interesting ideas. So one of those ideas is that since he is using this to update an existing application, he has to run this query, import the data, but then be able to do that idempotently. He needs to be able to run the query again sometime later and update his database. And as it is here, this is a projection. It has already erased all of the history that makes this a CRDT. So basically, this is in a CRDT, you've got three functions. So you've got your update function that takes current state of your data and some new information and updates it to some greater or equal value. And then you've got your merge function, which takes two values, two sets of data. One comes from another node, and it computes the least upper bound. So it merges those two values. But then you've got your project function, and that takes the value of the CRDT, which is some complex thing, and it projects it into a value that your application actually cares about. So project is a lossy operation. And so here we've already run project. So we've already discarded the information in that CRDT that allows it to be merged. So, I mean, I could explain all that to him, but the upshot is that, hey, if you're going to try to write some code that merges this in, you're going to run into some issues. And so we talked about different options for that. One of them is actually, hey, let's just run Jinaga JS inside of your application. Well, that's kind of difficult because his application is in .NET. But if Jinaga.net existed, run Jinaga.net in your application, and then have a service, that watches a queue and updates your database. And now you've got the power of the CRDT. But a second option, which is almost as good, is to turn this into a webhook. So let's go back to this specification. So let's suppose that I were to post this specification to a different endpoint. So rather than read, I post it to hooks. And then what I get back is, and then in addition to this specification, I post a URL. So maybe that's also part of the language here that's used specifically for webhooks. And then, anytime there is a new course, then it just posts that JSON to that webhook. Or anytime something about an existing course changes, it posts or maybe even puts that JSON to that URL. And then we can also do the delete. So anytime a new fact occurs that causes an existential query to return false, anytime one of these is removed, then post delete to that URL. And then we could even have parts of the projection, like like right here, catalog.office. Maybe inside of the URL language, we can include catalog.office in some curly braces or something to indicate that that is part of the URL. And so now you've got /Dallas /whatever, and that becomes the thing that you post to. And so using that, you can design your own webhooks with the specification language, and then now you just write controllers at those different endpoints. When you receive a post or a put or a delete, you just do the right thing on your database, and that is almost as good as having a replica of the CRDT running on your side. So that is a really tempting feature to implement next, but so far he hasn't said, yeah, let's do that, because that would be extra work for him.
Mm-hmm.
Making use of Jinaga directly in his application is also extra work.
Yeah. Yeah, and that would be extra work that he would have to wait for for us to get Jinaga.net to a point where you could actually use it, and that would put it past the deadline. We want to be able to have this integrated by the end of the month, so this is what we have to work for.
Okay. Last time I was wondering why would we not use the specification language as the final end language for every client?
Mm-hmm.
But going back to the link-like query language, because I always forget things.
Mm-hmm.
So I changed my mind. I said, let's use that link equivalent.
Yeah.
I think it would be sad to leave that out.
Yeah, I think so. Because you would have to publish this information somehow. Like right now, I just published it as a documentation. Mm-hmm. And then while you're writing it, you have to refer to it. We can make that a better process. So Caden, you were talking about language servers. This is exactly what would be what we could use the language server for is grab this information from the compiled code, like in this case the TypeScript code, and then use the language server understands the specification language, but then it also understands the model. So when I say arrow, I know that ImprovingU catalog has _in, so okay, let's go ahead and make that an option there so we can do IntelliSense. And then it could even fill that in automatically because it already knows that from the model, but it has to be part of the specification because the peer on the other side doesn't know that. So fill all that stuff in. Yeah, when you're writing this out by hand, there is a lot of redundancy. It's like, I just told you that this is an ImprovingU course, and so when I write this this condition that delete course is equal to course, I still have to say this is an ImprovingU course. Why did I have to repeat myself? Well, there's a good reason you have to repeat yourself here, but yeah, when you're writing this out by hand, that kind of friction does kind of get in the way.
Mm-hmm. So, I'm curious, what would be the bottleneck if we want to scale up Jinaga?
Mm-hmm. Yeah, I ran into that with this one. So here, this is me searching through all the courses. So right now you can see that it's all the courses in a particular semester. So I was looking through spring 2021, and I'm looking for a course that's not been deleted where there exists a session, not deleted, related to attendance, related to student IDs. So while I was importing the student IDs, I was looking back in time for a course where the small number of student IDs that I started with before I just kicked off the full import, where I had some test data where they were they were a student in that particular course and attendance was taken. And so when I first did this, I had the company as the given, so it was just scanning all semesters. And then I narrowed it down to, okay, just do one semester. With one semester, you can see that took a little bit of time. It took just over a second. But with the company, that query took a much longer time. So this is still a lot faster than the way that I was doing it before. So this one is optimized because it does set operations. It runs a small fixed number of queries against the database that's based on the depth of the projection, and then it iterates those collections, and even that iteration, it does that in a single pass, so that it merges the results into a hierarchy. But yeah, for a large scan of the entire data set, that's going to take a bit of time. The use of projections is really the thing that impacts the scalability. So if you keep your projections narrowly focused, then you get some pretty decent queries, even with large data sets. But if not, then projection is going to be a problem. But that's just the read endpoint. The other endpoint that I have not yet done, which actually is going to be the next feature. I'll hold off on the webhooks for now. But the next feature is the feeds. So yeah, I have settled on the name feeds, plural, for the URL, and so that feature doesn't execute projections, but instead it gives you all of the evidence so that you can execute them on your side. And the feeds are paged so that you can walk along a feed and bring in more and more of those facts. So with that switch, now we get the scalability back, because it puts the work of aggregating the data back on the client, and the client persists that data because now we are within the CRDT, so we haven't run the project function, and so it has all the information locally that it needs to run the projection, and so running the projection is no longer a scalability cost.
So would the message passing become the bottleneck if we have lots of nodes holding CRDTs?
Yeah. What I expect to happen is that so whenever you post a specification to feeds, that registers interest. So now the server knows that this client is interested in these feeds. So actually the word that I'm starting to use there is not server but replicator, because these are CRDTs and each one is a replica of the CRDT. So the replicator knows that that this client is interested in these feeds, and so it can share that interest with its peers. It can talk to peer replicas and say, okay, there's a client that's interested in this, and so that will build the kind of the trails through the distributed system through the network of interest, and it'll bring data back to the interested parties. So so that means that the network is going to kind of partition itself over time based on the parties who are interested in this are over there, so all that data flows there. Parties interested in that are over here, so the data flows that way. And hopefully you've got a human that is kind of watching this and understanding that, oh, we need to deploy some new replicators here and here in order to create that network. So if you do that well, then you should find that it's able to set up a pretty regular stream of a flow of information from replicator to replicator that then every client downstream can take advantage of. And so if there are 20 clients who are all interested in the same results, then the streams to produce those results will just move that data once, and then from that replicator and move it again. So you should end up being able to optimize that message passing. And the kind of the standard that I'm trying to hit is if a human were to set up some RabbitMQ queues and write some code, design messages, and make all this stuff work themselves, they couldn't do any better. And so I think we can approach that limit.
So will there be a guideline to do this, or I think someone will just broadcast everything and the whole network would blow up?
Yeah. If you do that, that's what will happen. So yeah, there definitely has to be some education around this. So written documentation, some videos, some courses. There's got to be a whole campaign around how to use this powerful tool correctly, so that you don't bring down your whole system. Yeah. If you make things easier, you make doing the wrong thing easier too.
Mm-hmm.
No, anyway, this already gives us the possibility to experience a little bit what it gives with a lot of data.
Mm-hmm.
What is hard to do in your own database.
Yep. Yep. So having 7 years worth of data in there. Just switching to. Let's see if I can run that real quick. So we've got the company, and then instead of passing in the semester, we are going to grab all the semesters such that semester arrow, and I can already see up here company is the role, but if I couldn't see that, then I would have to go to the documentation.
Because actually in Jinaga, in Jinaga we don't have any discovery feature to discover the model. Is that right?
That is right. It is up to the host language to do that for you.
Mm-hmm.
Yep. So the replicator that I'm talking to here at ImprovingUCourses.OurWebsite.net, that replicator, even though it has some application-specific code running inside of it, once you get past that, once you get down to the database, it doesn't know what the application is. So in fact, the way that I want replicators to be deployed in the future is that the replicator itself has very little knowledge. So the extra business logic that this ImprovingU replicator is doing, even that, I want that to become a client that is also deployed to deployed to the cloud somewhere. Yeah, so if we
then you're talking about the software that is generating the keys, that type of stuff.
Yeah, yeah. There's actually not much left in ImprovingU that has to be run as a client deployed to the cloud. But another example would be, one of the projects that I intend to work on is something that integrates Azure DevOps and Jira and Slack, and gives you a whole integrated chat ops experience for your dev team, and so there are going to be pieces of that need to call APIs in order to talk to Azure DevOps. Grab information from Azure DevOps and put it into the model. Take intent from the model and execute that on Azure DevOps, and then take the result of that execution, put that back into the model, say that intent has been satisfied. So so through chat, I say, I want to I want to notify testers of a new version or something like that, and then it says, okay, that I'll interpret as an intent to move a card from one state to another, so make that API call, and then when I get the response, put that back into the model, say, okay, the card has been moved. And meanwhile, another one is saying, hey, there's an intent to to chat or to email or whatever to this group of people, after the build has been completed. Okay, so following the build and putting a fact back into the model when the build completes is elsewhere. So those bits of functionality that call APIs and interact with external systems, those are clients of replicators. They are no longer bits of code running inside of a replicator, the way that ImprovingU was currently architected.
And then we will have a universal replicator which can be used for any application you want.
Yep, exactly.
Completely model independent.
Yes.
Okay.
Yep. So doing all courses in the company took 7.5 seconds. So still not bad, but but yeah, it's not the So if this were an even larger data set, then it would slow down even more. You doing this same thing in JavaScript using .watch, that took on the order of like 30 seconds. So it was a very inefficient n+1 times the to the power of the depth of the tree kind of operation. It was pretty slow, but yeah, this one does a really good job of just do all these queries at the various depths, take all those sets, merge them together by doing a single pass through the collections, and now you've got your results.
I'm thinking that if some queries are overlapping, can we catch in the overlapped parts so we don't have to do the same query again?
Yeah, so that happens when you do the replication on you do the projection on the client side. So you've replicated the data. So that replication itself is taking advantage of that redundancy. But then when you actually perform the projection, it has to so it creates a set of a set of SQL statements that have more and more joins in them, and so the earlier joins have to be repeated in the next SQL statement. But But then after that next join, since that is an inner join, it might exclude, if there are no successors, it might exclude the results from the predecessors. So so you still do the query with the smaller number of joins first, and then you do the query with the larger number of joins, and now you've got two sets, and then you walk through this set until the the ID changes, and then you move them both down and you continue walking through. So yeah, it still has to do a bit of redundancy in order for the projection to be able to roll up results and create these collections. But at the very least, you get to avoid that when you then replicate to another replicator, and so that's why it's best to have a local replicator. Yeah, I don't have one in this case. I'm going all the way back to the server. But if I had a local replicator and I just issued this query on that local replicator, then it would make sure that it's got all of its feeds up to date, perform that projection locally, and give me back a result much more quickly. And it won't be taxing the central replicator and then adding a whole bunch of load to the whole system. Yeah, so I'm pretty excited about getting a Jinaga-replicator Docker image published, so that you can just create a replicator as a container and start doing this. I don't have any write operations in this particular collection, but basically a write operation just looks like that. Well, except you can't do this in a write operation. You have to fully express the predecessors in write. But yeah, then you can just start writing some facts to your own replica. Start writing some specifications and build up your application from there.
Exactly.
Cool. So by this time next week, I should have the replicator ready to go, and have that out on Docker Hub.
Okay.
Yeah, the backend guys will be happy to upgrade the container.
Mm-hmm. Yep, I think so.
So we'll keep a look on Docker Hub. Jinaga replicator.
Yeah, and hopefully I'll also have time to get some documentation up on Jinaga.com describing the specification language and pointing to the replicator, so that you've got now a set of instructions for how to get your own replicator running and how to start using it.
Specification language is already described in that Markdown document.
Yeah. Oh yeah, it is. It is. Yeah. I described it before I wrote it, so that I. Yeah.
Perhaps it doesn't contain the latest, like the hash lookups.
That's true. Yeah. So I added that after.
Most of it is in it.
Mm-hmm.
I thought what you showed in Postman, that documentation was just a summary of what was on GitHub, but.
No, I completely forgot about what I already wrote in GitHub, so I wrote the documentation again. So I'll compare the two and see what's more understandable, and then I'll probably write it a third time and get it up on Jinaga.com.
Yeah.
Good. Then we will play a little bit with it. That will be nice.
Excellent. And
then on the .NET side, So actually, we'll have that that link, the link format.
Mm-hmm.
That's gonna be translated then into the specification language.
Yes.
And that specification language is sent over the wire to the server, to the replicator.
Mm-hmm.
But then for local processing on the local database, are we going link specification language and then local SQL, or do we do link directly local SQL?
I think we do link to an internal data structure that looks very similar to specification, but we don't need to get it all the way to the text representation of it. And then from there, the SQLite store can use that data structure. So yeah, we can use that same data structure to produce the text version of the specification as well. So yeah, it's link to data structure, and then from there either to SQL or to specification language.
Okay.
So if it's specification language, then you can post that to /feeds and set up your feeds that way. But then go to SQL and do your local query.
Okay. I'll start thinking about that. That's going to be a very difficult one.
Mm-hmm. Yeah. In fact, there is a class called specification that's already in the .NET code, and I think it has a similar structure to what this language ended up being. So yeah, it'd be interesting to do a comparison between those two structures and see what needs to change.
So that's called just specification, that class.
Yes, I believe so. Yeah, I think I think I used the word specification and projection in those classes, as well as those are the names of the things in the specification language as well.
Okay, I will.
So I
look
think
it
I
up.
was consistent, but who knows?
No, we will find out. No problem. Okay.
Excellent. Well, gentlemen, thank you so much.
Time for you to go work.
Yes, it is.
Time for us to continue work.
Yeah. Well, time
Oh, no.
for Caden to go to sleep.
Yeah.
Yeah.
Okay.
Hopefully the fighter jet won't be too loud.
Man, yeah. I hope everything is all right after after stirring the pot there. So
Don't worry too much about Caden. Often be scared of something is often worse than the problem itself. And I think that's what they are trying to do. Make people scared.
Yeah.
So
Hopefully we will be not the next Ukraine.
I think the China. I shouldn't say it on YouTube, but I think the Chinese are more clever than the Russians in this point.
Yeah.
Yeah. Okay. Okay. Have a nice week, and see each other next week, Thursday.
yes, indeed. See you then.
Okay.
Goodbye.
Michael, thank you very much. Caden, bye bye.
Thanks, Jan. Thanks, Caden.
Bye bye.